Hello everyone. Today we are going to learn 8.1. So it's chapter 8 and unit 3. So in the unit 3, we have chapter 8, 9, 10. And chapter 8, we have 4 sections, but then last section is about the summary. So I don't want to do that. Just 8.1, 8.2, 8.3. So chapter 8, it's about hypothesis testing. All right, so I wrote down what is a hypothesis testing. So hypothesis testing is a statistical method used to make decisions or draw conclusions about a population based on a sample data. So I made it think. So what is a hypothesis? We can think educated guess about a population. Then what is a hypothesis testing? Think is a way to check that guess using data. Make sense? Okay, very good. All right, so 8.1, logic of hypothesis testing. We have a learning objective here. Okay, so I'm gonna mention this one later. The logic of hypothesis testing. Okay, so this section is about this. I wrote down the story so that you can better understanding for this section, this chapter. So phone battery life. So I am working at Samsung phone company. So battery company claims their battery lasts 10 hours on average, but I suspect it's less than that. Then how do I prove it, right? So take a random sample of 50. I make just a small battery. I cannot use a lot, right? So, I mean, I have to buy otherwise. If they just provide me the as a free, then yeah, I cannot use all or more, right? So they have to do business, right? Okay, so take a random sample of 50 batteries and record how long it lasts, right? So battery life is less than 10 hours. Then I don't want to contract with the company, right? Yeah, because I want a more 10 hours or more battery life. Yeah. If the battery life is around 10 hours, yeah, absolutely. I want to contract with the company. Make sense? Okay, I have another story here. I am a high school principal. Last year, the attendance rate was 95%, which is good. But then this year, I think students are skipping more classes, so the attendance rate might have dropped. So how do I prove it? Take a random sample of 200 students and check their attendance records. If the proportion of students who attended the school regularly is lower than 95%, I will conclude that attendance has decreased. So conclusion, there is strong evidence that attendance has dropped this year. So I might decide to start an attendance improve program. So make sense what we are doing this chapter? Very good. Okay, so let's talk about this. So this is also logic of hypothesis testing. So according to the Gallup News organizations, 5% of US population is vegetarian. Aha. So we have that information. But then sample of 200 college students had 28 that identify themselves vegetarian. So let's calculate that. 28 out of 250. Okay, so I calculated 20 out of 250. So it's a 0.112. Then we make a percentage that 11.2%. Then actually this number is higher than from the Gallup organization, right? Zation. Okay, then statistically, how do you prove, right? So let's take a look. So we have, hold on one second. Okay, so we are using StatCrunch. This is from the binomial. So n equal to 250, and then proportion we put 5%, which is 0.05 right here. And then the number we had the highest, not high school, the college students, right? So 28 out of 250 we calculated earlier, right? So 28, then we get 0.000065, yeah, which is 7, right? Okay, so 0.00007, this means we get 7 out of 100,000 people, right? Yeah, we can interpret it this way, right? So fewer than 7 out of 100,000 people, right? Okay, so that means very rare, right? Very, very tiny chance, right? Okay, so we have two conclusions in that case. The rate of vegetarians is the same for college students, and we obtain exceedingly rare sample, less than 7 in 100,000 chances of that, right? Or the rate of vegetarians among college students is higher than for the rest of US population as reflected in the sample data, right? Okay, number one, this is a very, 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 stop me, very, 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 yeah, tiny chance, right? So we just take this conclusion, right? So because the chances that is a rare sample is so small, right? We conclude that rate of vegetarians among college students is probably higher than the rate of rest of the population. Make sense? Good. Okay, so let's talk about the definition here. So we have null hypothesis test. It's a statement that assumed true unless sample evidence indicate it is likely not true. Okay, so we using null hypothesis always for parameter equal to value. If statement of no change or status quo. The symbol for null hypothesis test is we read the null hypothesis test H sub 0, right? Or H naught, right? We did that before, right? All right. Alternative hypothesis test. So we are using H sub A, right? So we are using first letter A, alternative, right? So H sub A. And then it's a statement that compete with the null hypothesis test. if the null hypothesis appear untrue, then there is evidence to support the alternative hypothesis. Let me highlight. All right. So null hypothesis test always the claim. Yeah, we start with. And then alternative hypothesis always against the null hypothesis test, right? Hypothesis, all right? So think. Think. Start. Claim, yeah, claim. Alternative hypothesis against the null. Yeah. Okay. If there is no against the null hypothesis, there's nothing to do, right? Yeah. So the null hypothesis always equal to parameter and the value. So what was the parameter? Let's talk about that, right? Parameter we had based on the number based on population, right? So we have a P, which is population proportion. We have a sigma, which is population standard deviation, and we have mu, which is the population mean, right? So those are parameter. The volume is the number, okay? All right. So look, we have a left tail test, right tail test, and two tail test. So left tail test, look, so we have inequality symbol, left side, yeah, so left. So left tail test. So we get shading power will be left side. That's why left tail test. How about right tail test? Right tail test, the inequality symbol is the right side, yeah? And with the shading area part is the right side. Two tail look is not equal to the inequality symbol. Yeah, it's not equal to. So we have left tail, right tail, two tail. Yeah. Okay. So look, the important point, they say that the conclusion of hypothesis test is always to reject the null hypothesis, H sub 0, H naught, or fail to reject H naught or H sub 0, right? We never prove the null hypothesis is true. We either reject it or we passively allow it to stand. Yeah. So we are using terminology, very important, right? So reject the null hypothesis or fail to reject the null hypothesis. Yeah. So we are using two terminology in this chapter. Okay. Yeah. All right. So let's do example. So this is what we did earlier. So Gallup, new organization, 5% of the US population is a vegetarian. And then 20 out of 200, 12. So 28 out of 250 college students had identified themselves vegetarian, right? So we had 0.11, right? So higher, right? But then look, they also say that, can we conclude that rate of vegetarianism among college students is higher than, yeah? So last sentence said that is higher than for the rest of population based on this sample evidence, right? Okay, let's answer the first question. Identify the null hypothesis test. Yeah, so parameter. So we always using parameter equal to the value, right? For the null hypothesis test. Okay, so what is a parameter in the case? Okay, so the 5%, what's the 5%? Very good, it's a population proportion, right? So we're using parameter. So among P, mu, sigma, right? So we are using P because 5% is P, yeah? Which is the value. The value we are using 0.05, yeah? So we are using the number, right? So 5% is not number, it's a percent, right? So 0.5. Okay, second part, alternative hypothesis test. So we are using same value. I'm sorry, same parameter, same value, which is 0.05, right? So alternative hypothesis, we are using same parameter, same value, only inequality change, yeah? Whether less than or greater than or not equal to, okay? So what do you think? It's the last sentence say that higher than, right? Also, we can calculate 28 over 250. We have a 0.11. It's higher than 0.05. So it's higher than, right? Yeah. Greater than, same. Make sense? Okay. Now we need to identify whether left tail, right tail, two tail, right? So I'm using like a tail. This is a tail, like a, yeah. So this is a tail. So there will be tail is here, so right tail, right? Yeah. All right. So D it's about assuming the null hypothesis is the null hypothesis is true, right? Describe a sampling distribution. So in the sampling distribution, what we have to check? We have to check their mean and their standard deviation and whether the distribution is normal or not, right? So we have to do that. This is a kind of a review from the previous section, previous chapter, right? So I need a space, yeah. Maybe D is the next page. All right, so D, sampling distribution. So we are talking talking about the P, right? So what's the means of P hat, right? So mean of sampling proportion of sample distribution, or mean of sampling distribution of sample proportion, right? So which is a P, which is 0.05, right? What's the sigma of P hat? So there is square root P times 1 minus P over n, right? So I did not make a mistake, right? So okay, so there will be square root p in the case 0.05, 1 minus 0.05 over n, and in the case how many? 250, right? So 250. All right, so can you please calculate? Yeah, it's a 0.01378 for the small, then 0.0138, right? Okay, now, how about normal distribution? How do you check? N times P times 1 minus P must be greater than or equal to 10. So N in that case, 250, P 0.05, 1 minus P 0.05. Can you please calculate? It's 11, oh, barely make that, right? So 11.875 greater than or equal to 10 is approximately normal distribution, right? Okay, why we are doing this? Because we want to use a StatCrunch normal curve. Yeah, okay. So use probability to reject or fail to reject the null hypothesis test. Okay, let us do StatCrunch. No, let's just take a look. Okay, so let's take a look. Okay, just take a look this one because we know how to use StatCrunch, right? All right, so with the normal curve StatCrunch, we're using that. When we use a normal curve in the sampling distribution, sample proportion, right? So we're using mean, which is P, right? So we are using that. And standard deviation, which is the square root of P, 1 minus P over N, right? So that is sigma sub P hat, right? So same as mu sub P hat in that case, yeah? So we're using different number, right? And then in that case, it's a P hat. So what was the P hat? It's 0.11, how much? 112, right? So I think 112 here. So they're using 0.112 here. So that P hat come from 28 divided by 250, right? Yeah, so here we go. All right, so we input all the numbers, then the probability is, oh my gosh, so tiny, right? So look, 0.00000345, so tiny number, right? So since this is a very low, we take higher, yeah. Remember, yeah, we did earlier, vegetarian, right? This is the same question, right? Because the population probability is very low, so tiny number, right? That's impossible to have that, right? So we take must be the higher than the 5%, right? So we take alternative hypothesis test. Then we said earlier, we're using terminology reject or fail to reject. Yeah. Since we take the alternative hypothesis test, we do reject the null hypothesis test. Yeah, makes sense? Why we take the alternative hypothesis test? Sample evidence suggests that the alternatively is likely true. That means there is a strong evidence to support alternative hypothesis test, right? Okay. Let me write down. So there we go. So means that there is a strong evidence to support the alternative hypothesis test. All right, so we have another definition here. So we have a test statistic. So test statistic is random variable that is calculated from sample data and used in the hypothesis test to judge the claim. So we are using z-score as a test statistic, and p-value means the probability that sample statistic will be at least as extreme as the observed test statistic from collected data, assuming the null hypothesis is true. Okay, the p-value is always the area of tail, so tail probability. So p-value is the tail probability. All right, so p-value is the always tail probability, area of tail. Okay. All right, so we have a significance level of a hypothesis test is used to determine how rare or unusual, right? So what percent, what probability we are talking about unusual is less than 5%, which is 0.05, right? So we are using a significance level as alpha here. So we read alpha. Alpha, right? Okay, then must be 5%, which is 0.05. Yeah. Okay. Then there is a very important what we are doing with the p-value and significant level. So if p-value is less than the significant level alpha, then we do reject the null hypothesis. Okay, so that is a very important, right? So what we are doing, we check p-value, which is p-value is tail probability, whether left tail or right tail or two tail, right? Those p-value is less than alpha, then we do reject the null hypothesis. Yeah, this is the main concept we are doing, right? Okay. All right, so we have left tail test, then p-value is less than the test statistic. So test statistic, we talk about the z-score, which is z-test statistic. Yeah. And the right tail test, the p-value is greater than. So let me using the picture better, right? So better understand. So left tail test. So we have a z-test statistic here, right? And then that p-value, which is the probability, right? More left. Yeah. And then right tail test. Then the z-test statistic is here, right? And then p-value is more right side. That's the right tail test. Two tail test. So two tail test, both left and right for the p-value. And then z-tested statistic is here, right? Z, yeah. Okay, more left and more right for the p-value. That's the two-tailed test. All right, so let us do this question, example 5. Assuming the hypothesis test is conducted with a significant level 0.05, right? So that's the alpha. All right, Now, the null hypothesis, which is the proportion equal to 0.72, which is 72%, right? Alternative hypothesis test is less than 0.72, right? Okay, so identify the test is left tail, right tail, or two tail, right? So we're looking at the inequality. So inequality, this one is left side, so it's a left tail test, right? Okay, second part. If test statistic z equal to negative 1.74, z is standard normal variable, find the p-value. So let me bring the picture from the StatCrunch from the textbook, all right? All right, so let's take a look. So this is from the textbook. We are using z-score, negative 1.74. So this is a normal curve, right? From the StatCrunch, mean equal to 0. The standard deviation is 1. This is a z-score, right? So z. Okay, then the probability is 0.0409. All right? Okay, C part. Do you reject or fail to reject the null hypothesis test, right? So C, the p-value is less than alpha, we do reject the null, right? Okay, so p-value, which is 0.0409, let's compare with the alpha. Alpha equal to 0.05, what do you think? Less than? Yeah, it is less than, right? So then we do reject the null hypothesis test, means that there is sufficient or strong evidence to support alternative hypothesis test, right? Okay. All right, so let us do second question. So we have this hypothesis testing. So let's answer the first one. We have inequalities like this, yeah, right side. So it's right tail test, right? Second one, okay, so let me bring the StatCrunch picture from your textbook. Okay, so second one, what's the probability? So we are using a normal curve. This is z-score, right? So mean equal to 0 and standard deviation is 1. Z equal to 1.31 is given. And then what's the probability? Since the right tail, right? So we are using inequality greater or equal to? So 0.095, right? All right. So then what do you think is, do you reject or fail to reject the null hypothesis test? Okay, let's find out. So C, so P equal to 0.0951, right? 4 decimal places, then alpha equal to 0.05. What do you think? It's greater, right? So we have P is less than alpha, then we do reject the null, right? Hypothesis test. Okay, now it's greater, so we do fail to reject. So fail to reject the null hypothesis test. Why? because since there is insufficient evidence to support the alternative hypothesis test. All right? Okay, so we have the process of hypothesis testing. So the first step, so we need to determine null hypothesis test and alternative hypothesis test, right? So null hypothesis test always parameter equal to the value, right? And alternative hypothesis is always against to null hypothesis test. So it must be less than or equal to or not equal to, right? Okay, then we need to identify what is alpha. Most of the time, it's alpha is given, whether 5% or 7%, 9%. If not given, so we talk about the unusual, so 0.05. Yeah, but 99% is given. All right. Okay, then identify sampling distribution and verify. Why? Because we want to know, we want to use StatCrunch normal curve, right? So we do that. Okay, then after that, using the test statistic, which is Z-score, right? Now, use the test statistic to find the p-value. So by the StatCrunch, right? And then if a p-value is less than alpha, we do reject the null hypothesis test. If not, do not reject or fail to reject, right? So let's remember only one thing. Make 5 stars, right? This is the main concept. We are doing that. If p-value is tail probability is less than the alpha level of significance level, either way we called, it's given. If not, 0.05, talk about the unusual, right? Reject the null hypothesis test. Yeah. Why? Because there is sufficient evidence to support the alternative hypothesis test. Make sense? Okay, so you try this one then. And let's move on. All right, so now we have types of errors in hypothesis testing. Okay, so we have 2 types of error. One is type 1 error. So type 1 error is the error that is made by rejecting the null hypothesis when it is true, right? Okay, so this means when the null hypothesis is true, we should not reject, right? But then they reject by accidentally, right? By mistake, right? So not supposed to reject. Not supposed. Oops. Suppose. Reject. But they do reject eventually, right? Okay. Type 2 error is the error that made by failing to reject the null hypothesis test when it is false, right? Okay, so when null hypothesis is false, it's supposed to reject, but they did not reject. They failed to reject. They did not reject, right? By mistake or accidentally, right? So that's the type 2 error. So supposed to reject. Okay. Then the probability of type 1 error, they have that That's the alpha. That's come from, right? Significance level. Alpha come from. Probability of type 1 error. Yeah. And then we have a type 2 error. So probability of a type 2 error, that's the beta. Read beta. This is a alpha beta. I'm not sure. This is 2t or 1t. Both are Greek letter. So it was purged, right? Paused. Both are Greek letter, Greek alphabet. Yeah, the spell is correct. Beta, only 1t. All right. Now let's take a look at this table. Let's think. The null hypothesis is false. If the null hypothesis is false, then we do reject the null hypothesis test, right? So reject the null hypothesis test. That is true, right? Okay. Fail to reject, even though the null hypothesis is false, then that's type 2 error, right? Fail to reject, that's the type 2 error. The null hypothesis is true, then we do not reject. We do not reject. So fail to reject, that is okay, right? But then when the null hypothesis is true, then they reject. Then that's the type 1 error. Make sense? Yeah. That is a very confusing word, right? But when you read out loud, makes sense, right? Okay, so let's take a look at this one. We have the like a court system, right? So the so I cannot think. No, no hypothesis test. The individual is innocent, right? That's true, right? So like everyone is innocent until they what is called the judge said that make whatever. Okay, I cannot think right now. So alternative test, the individual is guilty. So opposite, right? So always alternative test is opposite of the null hypothesis, right? Okay, so individual is innocent, alternative, individual is guilty, right? All right, then type 1 error. Type 1 error. So we have the null hypothesis. So reject the null hypothesis, right? So type 1 error, reject the null when the null is true, right? That's the type 1 error. So let's read, let's take a look. The court can find innocent person guilty. They made a mistake, right? In this situation, the court reject the null hypothesis that the person was innocent, right? And instead find them guilty, right? They conclude they are guilty. Yeah, reject the null hypothesis means they conclude alternative hypothesis test. Yeah. Okay, so guilty. In this case, the mistake result on innocent person paying fines, going to jail, or both, right? Yeah. So alternative hypothesis in the case is guilty, right? Okay, type 2 error, failing to reject the null hypothesis test. when the null hypothesis is not true, right? Yeah. And then this color, fail to reject the null when null is not true, right? Okay, that means fail to reject. They conclude the null hypothesis test. Yeah. So the court can find the guilty person not guilty. Here, the null hypothesis that the individual is innocent is false, but they did not reject it to find them guilty, right? This makes result in guilty person not paying for crime financially through probation or jail. Make sense? Yeah. Okay. The word did not say earlier, right? Okay, so let's do this example, type 1 or type 2 error, right? So we have the same example, like a rate of vegetarian college students, right? Okay, so we had a p-value, which is 0.00007, alpha equal to what? 0.05, right? Which one is bigger? Yeah, p-value is smaller, so we do reject, right? We had that rejected the null, right? Okay, so what possible error we can make, right? So that means, hold on 1 second. So that means, let me think. We can make the error when the null hypothesis is true, right? Then we rejected the null hypothesis test, right? And that is error. Can you see that? So this was true, right? That means there's a strong evidence to support the alternative hypothesis test, right? But then what possible we can make error, right? So we can make a type 1 error. That is reject the null hypothesis test when the null hypothesis is true, right? Yeah, we're using this one, right? So that is not true, right? So when the null hypothesis is true, but actually this is not true. That's why we do rejected the null hypothesis test. Make sense? Okay, we focused on this one, not this one. Don't get confused with that. Rejected, rejected. Yeah. Make sense? Good. I am very sorry you did not say anything here, my word, right? So type 1 error, reject the null hypothesis test when the null hypothesis is true. So we focus on that one when the null is true, right? So that is not true, right? Yeah. All right. Let's move on. All right. So let's take a look this question. All right. So we have only one. The p-value is 0.1170. We compare with the alpha, which is 0.05. Which one is bigger? This one is bigger, so we fail to reject, right? Do not reject. Okay, then what kind of possible error we can make, right? So we not focus on fail to reject. we focus on whether the null hypothesis is true or false, right? So in that case, fail to reject, that means true, right? But then we make a error false, right? That's a type 2 error, right? So that type 2 error we can make. So there is a type 2 error. So that is fail to reject when the alternative hypothesis is false, right? It's not true. So we focus on when alternative is not true. Sorry about that. It's not true. Yeah, this is not true. Yeah, that's a false. If false, then we're supposed to reject, right? Yeah, but fail to reject. Make sense? All right. So we are done. Thank you for watching. You have great day. Thank you. Bye.